Good morning, squad. Today we're going to be talking about elements and compounds, and part 2 of this video we'll talk about chemical formulas and equations. Let's get started. So you all know from our vocabulary that an element is a pure substance made of only one type of atom. Yesterday we talked about atoms, and that's why we can add this part of the definition on. It's only one type of atom, which means that it is pure. It cannot be broken down any further. For example, the element neon is made only of neon atoms. The element gold is made only of gold atoms. How are elements different from each other? So elements differ by their number of protons. For example, carbon has 6 protons, and copper has 29 protons. This is what creates the differences between them and makes differences in their properties. The elements are all organized on the periodic table of elements. Each element has its own square. On top it has the number of protons, and you can see that each element has different protons. None have the same number of protons. Elements can be represented by their symbols. There are 2 rules that you always have to follow when you're writing these symbols. Number 1, always capitalize the first letter. So for elements like carbon and nitrogen, where they only use one letter, it's just a capital C and a capital N. The second rule is, if there is a second letter, it has to be lowercase. So for elements like chlorine and sodium that do have that second letter, you can see that it's lowercase. Chlorine is capital C, lowercase l. Sodium is capital N, lowercase a. Where do elements get their names, or who created these names? Some elements get their names from Latin and Greek, which are usually the root of the English language. Copper, for example, Miss G is not even going to pretend to pronounce this word because I don't want to pronounce it wrong. And of course the symbol is Cu. Iron, for example. And notice that the symbol is Fe. Finally, you see lead. Lead, I think, is the best example of the root coming from a Latin word because P and B do not occur anywhere in the word lead. It seems so different, but you can very clearly see when you look at the Latin root why P and B were chosen. We drink water, we breathe out carbon dioxide, and we use salt in our foods. But what do all of these substances have in common? They are all compounds. So let's talk about compounds. You are probably more familiar with elements in their compounded form than in their natural form. Elements are rarely found in nature just as pure substances. They are usually found in compounds mixed with other substances. 2 or more elements that are chemically combined is a compound. For example, salt, NaCl, sodium chlorine, water, H2O, hydrogen and oxygen, and carbon dioxide, carbon and oxygen. When elements combine to make a compound, the new substance has properties that are different from the original. This could be a new color, odor, and texture. For example, we were just talking about salt. Both of these chemicals individually are actually very toxic and harmful to humans, but when they create a compound and make table salt, it's perfectly fine for us to consume. So for this next part of the video, I want you to pause and go to your slide and fill in the practice portion that says element or compound. So just look at the name of the substance, at the chemical equation written for it, and write if it is an element or compound on your playlist. Okay, let's go over the answers. Methane is a compound. You can tell that it's a compound because it has two uppercase letters written in it. You can tell that this is carbon and this is hydrogen. So it is a compound. Sulfur is an element. You can see that the only element that it contains is just this uppercase S, only sulfur all the way throughout. It is not bonded or compounded with anything. Hydrogen peroxide is a compound. Sulfuric acid is a compound. Ozone is an element. And nitrous oxide is a compound. Go ahead and make any adjustments that you need on your playlist. You can pause the video here. Next up, we're going to be talking about chemical bonds, or the things that hold atoms together and create these compounds. Atoms bond together in two ways. They can either share electrons in their electron cloud, or the electrons can move from one atom to another. One word that I know you're all familiar with from our vocabulary is molecules. One or more atoms that are bonded together are called a molecule. Molecules are the smallest part of a compound that keep the same properties of that compound. So if you broke a compound all the way down to just its molecules, it would still have the same properties that the whole substance has put together. For example, we can see oxygen, carbon dioxide, and water are all molecules.